All right, let's go ahead and take a look at section 4.5. It's titled Making Connections. And what this has to do is with the idea of connecting what we were doing in chapter 3 with confidence intervals with what we've been doing more recently in chapter 4 with hypothesis test. And when I say that, what I mean is when we get to the conclusion of a hypothesis test, the desire or the hope is to be able to reject the null hypothesis. And we know that we're able to do that anytime that the p value is smaller, smaller than alpha. Again, smaller p values indicate less likely that an observed result was a fluke. It gives us stronger evidence against the null in favor of the alternative. And then, of course, we know that if the p value is too large, then the other conclusion is that we're not able to reject the null hypothesis or we fail to reject it. Now, when I say that we're going to tie this back into what we were doing in chapter 3 with confidence intervals, is the confidence intervals, remember what those did, is those were giving us a range of plausible values of from here to here is most likely to be where the truth is regarding some population parameter. Now, what we're going to be doing is getting locked in to the null hypothesis and specifically a value that it is represented by. And if our desire is to be able to reject the null hypothesis, then what needs to happen is that it not be contained in the interval. Because remember, anything in between here and here is known as what's plausible. And if the null hypothesis happens to have a value that is within here, it's likely to be the truth. And so, for that reason, we wouldn't be able to reject it. If it's on the outside, maybe it's too low a value, then you can reject it. Or maybe on the right side, maybe it's too big of a value to be considered plausible. Same thing, where you can reject the null hypothesis. Then I've also got there that if the null value is in the range of plausible values, you can't reject it. So let's see how this works. Now, we did one back in chapter 3, which was looking at the whether 98.6 is plausible or not as a value for the normal human body temperature. We're going to start off by seeing what's being tested with our HO and HA. Right here's the magic word. We wish to test if there's evidence that the mean body temperature differs from 98.6. So again, nothing new here. This would be mu 98.6, mu 98.6, where the null hypothesis is saying that the average temperature for all people who are healthy is 98.6 or close to 98.6. And then the alternative is coming along and saying, no, it's not 98.6. It's something else. Now, what we would do is we would gather a sample and we would do a p-value to see whether there's enough evidence that it was a fluke to be able to reject or not reject. But now what we're doing is switching it back to chapter 3, that suppose they bootstrapped based off of a sample and they got something between 98.05 as the lowest that the normal body temperature might be and 98.7 as being the highest that it might be, with 95% assurance is 98.6 in that interval. Well, here it is. 98.6 is not in between those two numbers. It's actually like over here. Like it'd be something like on the outside, like too big or too large of an estimate. Let's just make a couple things. The explanation being 98.6 is not contained in the interval. So if it's not in there, 98.6 is not in the interval, we can reject it. Yeah, 98.6 is not a plausible value for what might be the true normal body temperature. All right, but that's what this lesson is all about. Is rather than using p-values, which we are still throughout the rest of the class going to be at times using p-values, actually a lot of times using p-values, just know that also whenever you're looking at articles, they might actually do a p-value and a confidence interval kind of side by side, both showing like, hey, here's our ability to reject, and then also here's our interval that suggests what's true. But they should always match. Anytime you're doing a 90% confidence interval, that corresponds to a 10% level of significance. 95 goes with a 5, and 99 goes with a 1. And these were some things that I was already mentioning whenever we do decide whether we should use a 1% or a 10%, uh, based on whether the study is more in the nature of being a serious study or not. Um, but let's try some of these that don't have any context. It's mainly just an exercise of knowing whether we should reject or not reject each of these null hypothesis here. And again, that's what we're locked in. For each of these, we're trying to see whether we can reject the HO, the null, which these are all represented by some value. Now, before I forget, since this right here is going to be referring to a 95% confidence interval, if there were a p-value, it would need to be that it's less than 5% chance of being a fluke. And then you can see both of these here. They've got a 90 and a 99. Each of these would correspond to a 10% and a 1% level of significance. But now for the reject or do not reject. For part A, the goal or the desire is to try to reject the null value that's saying the average for some population is 18. And based on this interval, can we reject 18? As long as it's not in there, you can reject it. You can reject the null. Now, some of the homework is going to ask you to explain. Some of it's not going to ask you to explain. This one's not, but I'm going to go ahead and do it just in case. 18 is not in the interval as our reason why we're rejecting the null. Now, B, the null is what we're trying to reject, which someone has come along and said that the proportion for some population parameter is 65 or 0.65. And based on the interval, again, that would have been something that they bootstrapped based off of a sample. They got something between 62 all the way up to 80 is plausible. And so can we reject 65? All right. On this one, 65 is in that plausible range, so it might still be the truth. So we cannot reject it. Now, again, the answer key is going to have do not reject HO, but if you want to instead write fail to reject, that also works. And then again, some of the homework's going to ask you to explain, some of it won't, but on the test it will ask. So I would just maybe go ahead and get into the habit of just putting it. 0.65 is something that we cannot reject because 0.65 is in. Now, what I like about A and B is that for each of those, we were able to see specifically what the null value is. Null value was 0. No value was 18. No value was 0.65. And then for C, this is what we're trying to reject, which someone is saying in the null or arguing that the proportion for group 1 is the same as the proportion of group 2. So if we're saying that they have the same value, that's also a way of saying that they have no difference. Which what number comes to mind when we think of someone saying, "Oh, there's no difference between those two things." It's not the first time we've seen this. We've seen it before in chapter 3. This would be a null value of 0. And that's what we're trying to reject. And based on this interval, can we reject 0? Or is 0 plausible? Now, notice this one goes from a negative number to a positive number. So 0 is in there, which means we can't reject it. Now, again, this was not asking for any kind of explanation, but if we did, it would be really short and sweet. 0 is in the interval. Now, those are just to kind of get us warmed up. I want to go and do one of these. That's the same thing. It's a hypothesis test that rather than using a p-value at the end to not reject, we're going to use a confidence interval. Now, keep your eye on the null hypothesis as what it is that we're trying to reject. Go ahead and read the prompt. And I'm starting to think that hopefully we've gotten through enough of these lectures, that you have done enough homework to where your writing your HO and HA is becoming a little bit more routine. I will once again give it away that the word test, the statement with the word test, is the one that's going to be your big trigger word for what your HO and HA should include. But go and read the entire prompt just to also see what the whole study was about. All right, here it comes. So they wanted to test whether the proportion of all adults 18 to 29 who say yes, that it's too hard to adopt, that a child needs mother and father to grow up happily, whether it differs from 50%. So you have your equal sign, you're not equal to because of the word differs. This was a study about proportions. 50% differs from 50%. Now, again, the only time that we ever use Muse is if it ever says that this is a test or a study about means or averages. Now, keep your eye on the null. That is what we're trying to reject. 50%. Based on this interval, can we reject 50%? The short answer, no. 0.50 is in the interval. So we do not have evidence against it. So the generic formal conclusion is do not reject the null or fail to reject the null. And they snuck it in here. It's 95%. So the p value that would correspond to this would be a 5%. But nothing's changing. We talked about in 4.3 that if ever you say that we do not reject the null, we say that there is not enough evidence for the alternative. But we talk about what this means in the story, right? We're not just going to say there's not enough evidence for HA. We want to give the context. There's not enough evidence to support or to suggest that the proportion of, and really I'm just using a lot of their words. This is a study. This is really important also that it wasn't just about the people they surveyed, but about all U.S. adults 18 to 29 who say child needs father/mother, both of those, to grow happily differs from 50%. 50% is still plausible. Now, we're not going to say that we accept that it's 50%. We're just saying, there's not enough evidence to suggest that it's something different than that. Now, I want you to pause the video, and here's what I want you to do during that time that you have me pause, is I want you to go and read this prompt. I mean, there's the word with what they're actually testing, or at least give that away. And I want you to use that to write what the HO and the HA for this. Like, what are the two different arguments? I also, once you do that, want you to think about if you've been given these rows and these columns of information about what was being tested and the samples, you'll see pretty quick that this is about two groups. I want you to see if you could take only what you need. Now, there's going to be some of these columns and rows that you're not even going to need, so you can just scratch them out. But what you do need, I want you to take those and build your fractions down here and go ahead and subtract so that you can get your statistic. 3 decimal places will work. And you might also, for this one, consider, no, we don't do it all the time, but you might also consider putting right here both of the decimals before you actually get the final difference between the two groups, just so that you can see which group had a higher or lower value than the other. But go ahead, just pause me, do part A, do part B, and then we'll do this together. All right, here we go. Now, they wanted to test to see whether there's a lower proportion that relapse if using drug D, the new drug, as opposed to those who don't. Which for this one, they ended up doing drug D versus those who are doing a placebo. So maybe they do the same, or maybe one of them is lower. So that's our starting of the HO and the HA. We're going to have proportion for the new drug, proportion that we're using placebo. maybe you have the same amount of individuals relapse. Now, again, for the context of this one, when someone is trying to break free from an addiction, we don't want them to relapse. Again, relapse is the idea of them going back and returning to the addiction. They failed to break free. All right. So we want those to be as low as possible. Now, what they're doing here is trying to test whether the new drug D, is able to do better at helping people break free from the addiction than those that are just using like a placebo. So this is a left tail test. I'm just going to go ahead and put that just in case we need that. Now, one little thing that we haven't needed a whole bunch of a reason to keep it in mind until now is whenever you see a null hypothesis where you're saying that both groups are the same, it's either you're saying that they're the same or it's another way of saying that there's no difference between them. Now it's important to keep track of zero. That's to say that there's zero difference between them. So that's the null value whenever you're doing two groups and they're the same. And it'd be also the same idea if we were doing like averages. Now, for what actually happened, we're going to do drug D minus placebo, proportion for those using drug D versus the minus the proportion of those that are using the placebo that relapsed, right? That's the key word here, that relapse. So you actually don't end up needing the numbers for no relapse. So 10 out of 10, 24 who are using the new drug relapsed, minus 20 out of 24. And already you can see a big difference there. 10 versus 24, like almost double the amount relapsed when they were using the new drug. Now, here's what I'm going to do. I'm going to go to just do the fractions in my calculator. 10 over 24 minus 20 over 24. And we get negative 0.416666666, which would be negative 0.417. Which right now, what it's doing is suggesting that the new drug, desipramine, was better. And again, that's because when we did drug D minus placebo, we got a negative number, which is suggests that the whoever was that first group was lower by like about 41, 42%. But if you also want, if you're ever having, second guesses about who's better, who's worse, if you just do 10 over 24, that's 0.41666666, like 41%, 42% almost relapse with the new drug. And if you do 20 over 24, this is like 0.833. That's just another way to show you that the new drug was lower, like 41, 42%. The placebo group, like about 83% of them. In other words, it's totally okay if you want to just somewhere nearby put like what they were in decimal versions to see just a lot more immediate who was better. Now, what I said on the last page, I'm going to say it again, is we want to be locked in at what it is we're trying to reject. I'm going to go and put circles around both things. We're trying to reject the idea that the two groups did the same or that there's zero difference between them. So 0 is the number that when you come to part D that you want to see if you can reject. And just like we were doing on some of the earlier examples, can we reject 0 based on that interval? And that interval came from them doing a sample, bootstrapping to see what the difference was, and they got double negative. Which is just to say that here, whenever they check, desipramine, the new drug, was lower And then whenever they did the bootstrap, it was lower, lower. 0 is not in the interval. And since 0 is not in there, can we reject it? Yeah, it stays completely negative. If it had switched from negative to positive, then we would say, yeah, 0 is plausible. Since it's not, no, 0 is not in the interval. So we can reject the null. Who was trying to say, like, we can reject that because it was trying to say that there's zero difference between the two groups. And no, there is. There's a big difference. But that's the explanation that I want you to use. Either 0 is not in there, 0 is in there. In this case, since it's not, we can reject the null hypothesis. Since it was a 99% confidence interval, that would correspond to a 1% alpha. And we would say that there is enough evidence to support. Now, this is your conclusion in context. So this is your generic conclusion or formal generic conclusion. And then now we want to say there's enough evidence for that. And I just circled it up there that the proportion that relapse with the new drug is less than the proportion of those who don't use it. And you're welcome to paraphrase it a little bit. There's enough evidence to support that a lower proportion relapse if use that new drug. And if you write something like that, that is enough. Tying it back into the big overall goal of the story or the study. All right, but I will go ahead and end the recording there. Another short lecture, but after this, we'll be moving on to chapter 5.